Imagine you're in a pitch black room. You're sitting at a table and you can't see anything at all. On the table is a deck of 52 cards strewn about the surface. You can feel these cards, but you can't see them. You are told that exactly 10 of the 52 cards are face up and the rest are face down, but you don't know which ones. Your goal is to create two groups of cards so that the two groups contain exactly the same number of face-up cards. So for example, a solution might look like this, because the two groups, which I've called A and B, each contain two face-up cards. Just to be clear about the rules, the groups have to contain at least one card. They can't be empty. The two groups you make do not have to be the same size, and you are allowed to flip cards over. But you are completely blind and have no way of telling which 10 cards are facing up. Like most great puzzles, this seems utterly impossible at first glance. What amount of sorting and flipping can make up for the fact that you can't see the cards? But also, like most great puzzles, the solution is beautiful and elegant, with no gimmicks or tricks involved. This really is possible. If you'd like to think about the puzzle on your own, then pause the video now, and you know where to find me when you're ready. Let me know what solutions you've come up with in the comments. So here's the solution. Pick up any 10 cards you want, and put them in Group A. Put the remaining 42 cards in Group B. Now, flip over all of the cards in Group A. But don't flip any of the cards in Group B. They'll remain in their original orientation. And that's it. It's really that simple. You just pick up 10 cards and flip them over, and that's one group, and the remaining cards are your other group. But why does this work? How do we know that Group A and Group B have the exact same number of face-up cards once we've done this? The easiest way to see this is by example, so let's try that again. When you pick 10 cards from the table, you have no idea how many of them are face up and face down. Suppose, for example, that one of the 10 cards you picked up happens to be face up and the other 9 are face down. This means that Group B must have 9 face up cards in it, because we know we started with 10 total face up cards and only one of them is in Group A. So when we flip over the cards in Group A, notice what happens. All of the face down cards become face up, and all of the face up cards become face down. In this example, there was only one face up card in Group A when we picked it, and so after flipping, there are 9 face up cards in Group A. And remember, this is exactly the same number as in Group B. So that worked in this example, but the solution has to work in all cases. So what if Group A had a different number of face-up cards in it? So let's flip the 10 cards back to their original orientation. If our 10th card in Group A happened to be face-up instead of one of these face-down cards, then there'd be 2 face-up cards in Group A, and only 8 face-up in Group B. So then, when you flip over Group A, it will have 8 face-up cards, just like B. So the same idea works regardless of how many face-up cards you happened to pick in Group A, because the rest of them will be in Group B. Beautiful. Note that there's nothing special about the number 52 or the number 10. This solution works with any number of cards on the table and any number of them that are face-up. The key to making it work is that if you start with 6 face-up cards, then you only put 6 cards in Group A and flip them. If you start with 30 cards face-up, then you put 30 cards in Group A and flip them, and so on. I love this puzzle because it seems impossible at first, and yet the solution is so elegant and satisfying. I am a puzzle guy, so I make videos of logic puzzles like this one, chess puzzles, and I make videos of me solving the daily New York Times crossword puzzle in real time. If that stuff interests you, consider clicking the red subscribe button below the video to keep in touch. Thank you so much for watching.